The fourth question of LeetCode 75. So can place flowers as title. So in this question, what we have given is that we're having a flower bed, and we're having some flower pots. So we can imagine flower bed as size of n. So we can they have given the size of the flower bed and the array of the flower bed is that the each element, if it is 0, then there is a flower bed, and if there is 0, then there is no flower bed. If it is 1, then yes, there is a flower bed. Sorry, there is a flower pot is present. So that's it. So he's asking that, and he has given no two flower pots can be adjacent. So if one flower pot is at index I, then I plus 1 में flower pot नहीं हो सकते. So that's the only condition is given. So he's asking that he is having some n. There is a small n. So he's asking small n number of the another flower pots, and we want to check whether we were able to keep the flower pots in the given flower bed, these n flower pots in this flower bed. If yes, then return yes. If no, then return false. Such that this condition, no two flower pots are adjacent to each other, should be satisfied for sure. So this is the question problem statement. We just need to return the output as true and false. So here the base case is that, so no two flower pots should be adjacent. So we should have a 3 consecutive blocks as that all the 3 are having zeros. Sorry. So all the 3 are having 0 for ith index and I plus 1th index and I minus 1 index. If all these 3 are zeros, then we're having one unit such that we can keep flower pot over here, and that becomes 0 1 0 the next. And then we need to check how many number of units such like this we're having in a given array of a flower bed, and if the count of these units if it is greater than or equals to small n, then return true or else return false. So this is not only the single condition, we're also having some edge cases. So edge cases simple edge cases, the single unit we're having, if it is 0, then return 0. For single unit we are not having I plus and I plus 1, right? If single unit we're having 0 and n is equals to 1, then return true. If it is single unit, if it is 1, then n is equals to 1, return false. So this is the first edge case. And second edge case is, in the given flower bed, the starting first 2, if these 2 are consecutively zeros, we're not having a previous element before the starting element. So here we just need to check only for 2, and if both are consecutively zeros, then we can keep 1 over here. The same condition exists for n the size is equals to 2. So we'll be checking this edge case, and the third edge case is that there's ending, the same thing at the ending. So at the ending if last 2 are zeros, then we'll be increasing a count, and we'll be changing this 0 to 1 so that we can check after this checking in this base case. So as soon as we have counted, we'll increase the count of the particular thing, and we should keep the ith index to 1 such that for the consecutive, if we are having consecutively 4 zeros, and these 3 are 0 and these 3 are 0, but we can't keep 2 ones at here because they will be consecutive. So as soon as after checking this to be 1, we just need to keep 1 over here such that duplicates will not be formed. So that is the logic behind this thing. So if we check in the code, console, yeah. So this iOS based English Studio and scene.die, cout.die, these are for increasing the code's performance, decreasing the code's runtime. So I have initialized the count to 0 and taking the size of a flower bed. So I'm checking the first thing, the simple thing. We'll be going with the simple things and such that the time it will be decreased, and then we'll be going to the base case at the ending. So that's my logic. So n is equals to n and small n is equals to, we're having only one thing and that's 0, then return true or else return false. And if we're having n is equals to 0, like we don't need to keep any flowers into the flower bed, and we just need to simply return true. If n is greater than or equals to 2, then we will be checking to the third edge case, that the last two, sorry, this the if n is greater than or equals to 2, then the second edge case, if flower bed of 0 is equals to 0 and flower bed of 1 is equals to 0, then the count is greater, we'll be increasing the count and we'll be keeping the first of thing into the 1. We'll be changing because we'll be keeping one flower pot over that particular index of 0. So that's the kind, and this is the third edge case, n minus 1 and n minus 2, the last two cases. And for this size should be greater than or equals to 3, because if it is at least it should be 2. If it is 2, it will all be checked into this. So why to check it again? So if n is greater than or equals to 3, we will be checking to the last two as 0. So if that is true, then we will be increasing the count, and if it is not, we will be just keeping the count as 0. So these are the edge cases, and now we are with the base case. If I is equals to, we will be having checking from I minus 1 I to I plus 1, right? So we will be starting with I is equals to 1 and 1 before the last thing. So flower bed I is less than flower bed of size minus 1. So flower, and this is the base case, flower bed of I is equals to 0, I minus 1 is equals to 0, I plus 1 is equals to 0. Then we'll be increasing the count and flower bed of I is equals to 1. So if n is less than or equals to count, we will be returning true. If n is greater than or equals to count, we will be simply returning false. So that's the code over here. So we're having simple 3 base cases. So edge cases is important. Base case, this we can get easily. The thing we'll be having wasting our time is checking the edge cases itself. That's the trickier part in DSA. I've already submitted this and it got it got only 3 milliseconds of runtime and base 99.83 users of C++. Memory is also fine. So that's the code for this thing. Thank you.